Hey everyone, today I've got an iPhone 12 for data recovery. Customer says the phone is totally unresponsive, no power, no charging, nothing. As you can see, the front glass is cracked, but the back glass looks intact. So the first thing is obvious, we'll plug it in and check how it reacts. Nothing is happening. No empty battery icon, no vibration, no response to the cable whatsoever. Just to rule out the basics, I'm going to plug in my personal phone using the same cable and charger just to make sure everything is working properly. And we can see my phone reacts instantly, but the original phone is doing nothing. At this point, it's time to open the phone up and move into a deeper diagnostic. To eliminate any possibility of a bad display, I've connected a known good test screen. Next, I'm going to be powering up the board directly from a lab power supply to see if the logic board is even attempting to boot. I turn on the power supply and press the phone power button. There is a response, but not a good one. You can see that the current briefly spikes to around 10 to 11 milliamps, then instantly drops back down to 0. This repeats every time I press the power button. That right there already tells me we're dealing with a motherboard-level issue. So we'll pull the logic board out of the housing and take a closer look under the microscope. So the first thing I'll do is remove all the stickers. At a glance, the board actually looks pretty clean. No signs of liquid damage, no burn marks, no obvious physical damage, and no visible signs of previous repair. No one's been poking around in here, at least where you'd expect to see it. Since this is a stacked 2-layer board, most of the critical components are sandwiched inside and can't be inspected externally. We can look at the NAND memory. I'll always start by searching for visual clues, and in this case, something almost immediately caught my attention. The underfill around the NAND chip. Underfill is that black epoxy used to protect the chips from moisture and to mechanically reinforce them. Right away, I didn't like how this one looked. The texture is off in some areas, it was matte in others, and in some places it was reflective. That kind of contrast just shouldn't exist on a factory original board. On top of that, along the edge of the chip, I noticed wave-like patterns in the compound, something you just don't see from the factory. It seems this chip was removed previously and the underfill was reapplied manually with a syringe. That tells me that this is a refurbished logic board. Boards like this are extremely common in refurbished phones reassembled overseas in China and India. Other than that, the side frame of the board looks pretty clean, no solder splashes, no obvious rework marks. That's definitely not a great sign for a data recovery case, but we're not going to stop here. We'll dive into all our potential options for recovery. So now it's time to split the board and see what's really going on inside. I'll use this preheater to separate the layers safely. Now, once our board is open, I remove the factory thermal paste, and honestly, things don't look terrible in here. No cheap flux, no fingerprints, no grime all over the place. One thing that does catch my eye, this shiny chip with those rainbow streaks. This chip only handles power for the Face ID sensors, but what I'm looking for is signs of rework. Uneven underfill, signs of overheating, or solder balls that have squeezed out from underneath the chip. You can see the underfill is clearly uneven, there are air bubbles, and the coating is inconsistent. On one side, you can even see a solder ball through the underfill where the CPU mounts to the motherboard. Seeing all this really confirms that this is a refurbished board. Let's try powering up just the top board on the lab power supply one more time. And we can see the result is the same. Yep. Given the poor quality refurbishment and the current readings we're seeing, the most likely causes are either a CPU issue or a memory issue. I'm going to start with the NAND. It's faster and easier to remove and reball. If the current behavior doesn't change, we'll move on to the CPU, inspect it, and attempt to reball. Now that the NAND is off and everything is getting cleaned up, I want to check how the board behaves without it. Under normal conditions, the iPhone without a NAND should pull around 60 to 80 milliamps from the power supply and show up on a computer in DFU mode. Let's see what happens this time. And nothing's changed. The behavior is exactly the same. At this point, there's about a 99% chance we're dealing with a CPU separation issue. So the next step is pretty clear. We're pulling the CPU off the board, checking the pad surface underneath, and then reball the chip. Right after removing the CPU, one thing became very obvious. There is an unusual amount of underfill stuck to the chip. Anyone with iPhone repair experience, starting with the iPhone 12 series, Apple switched to a different type of underfill. When you remove the CPU, almost all of it should remain on the motherboard, and only tiny bits remain between the solder balls on the chip. Here we can see almost 80% of the underfill remained on the CPU. This tells me the underfill was reapplied during refurbishment and is the older type used by Apple. Now we'll clean the board, clean the CPU, reball it with fresh solder, and get it back on the board. With a bit of luck, we should see a completely different result. So we can see here, our CPU is going on perfectly nice and flat. Before reinstalling the NAND, I do want to check the current draw one more time. We should see around 60 to 80 milliamps on the power supply, and that would mean we've fixed the root cause. At that point, with the NAND still off, the phone should show up in DFU mode on our PC. If that checks out, we will solder the NAND back on and power up our iPhone. And there it is. We see 78 milliamps on the power supply. Everything is looking good. Let's get the NAND back on the board and see if this data recovery is a success. And now we come to the moment of truth. Will we see the Apple logo? It's a little tricky hitting the power button context here, but I'll make it work. And there it is, the Apple logo. The phone is booting. The device powered on successfully. We have fixed the issue. Now the next step is to get the passcode from the client, create a full backup, and safely extract the data. Thank you for watching Salvage Data Recovery Services. Please consider subscribing. Have a nice day.